Okay, continuation of the transient problems. Last class also we solved some problems. Now this is another problem. Laplace transform of voltage across a capacitor value of 1/3 farad is given by Vc of s equal to so and so. What is IC0 plus? What is IC0 plus? So how to solve this? Using initial value theorem, using our IC of t. First, let us do this. IC of t is equal to C dVc by dt. So, what is Laplace transform? IC of s is equal to C into S into Vc of s. So, initial values anyway 0. So, and in this simplify, C is 1/2. So 1/2 into S into S plus 1 by cube S square plus S plus 1. Now, one lengthy method is inverse of this. Inverse Laplace transform. This is IC of t. Replace t with 0. You get the answer. But that is a lengthy method. Now, using initial value theorem. Using initial value theorem. So, what is that theorem is? F of 0 is equal to limit s tends to infinite s into f of s. So these properties you studied in Laplace transform. But here we want IC0 s equal to limit s tends to infinite s into IC of s. So what is IC of s is s by 2 s plus 1 by s cube plus s square plus s plus 1. So this we have to simplify. How to simplify this one? Limit s tends to infinite s square by 2. Numerator s is common, 1 plus 1 by s by s cube common, 1 plus 1 by s plus 1 by s square plus 1 by s. So here s square into s cube, this cancel, and s tends to infinite. This is 0, this is 0, all zeros. So you get answer of 1/2. So if you use initial value, you will get the answer easily. Otherwise, inverse of this, then replace t with 0. But finding inverse is time consuming. S power 3 na, you have to factorize. So it takes a lot of time. And this is the best technique using initial value theory. So the value of initial current is, to solve this type of problems, we need some background information. So what is that we should know is, if I take one inductor in time domain, so V of t we are applying, the current is I of t inductor L. So what is the equation? V of t is equal to L into dit by dt. So we know this formula. Apply Laplace transform. V of s equal to SL I of s minus Li0 minus. This is in S domain. So I can replace this time domain inductor using S domain equivalent. So V of t, change it to V of s. This current is I of s. So here time domain we have written a mesh equation, we got this. Here also we have to write a mesh equation to get this. So V of s is equal to what? I of s into SL. So this must be S reactance. Then all are in units of voltage. So this must be a voltage source minus plus because of this minus. But what is its value? L I 0 minus. Li 0 minus. Now you compare this with this problem. When you are comparing, what is the inductor value given here? 2 millihenry. 2 millihenry means inductor value given. But here there is a voltage of 1 millivolt. That means Li0 minus value is how much? This Li0 minus is equal to what? 1 millivolt. 1 millivolt. But what is asking the value of initial current? So we want I0 minus equal to 1 millivolt by 2 millihenry. So milli cancel, 1 by 2 amps. This is the answer. So with this equivalent, we got the answer. This is in time domain, this is in frequency domain. Frequency domain, we can also represent in other equivalent. So this is in series form. What is the parallel form? If it is a parallel form, solve for I of s. Otherwise, I'll write one more step. SL I of s is equal to V of s plus Li0 minus. Then we want I of s. Current form I am writing. So that is V of s divided by SL plus LL cancel, I0 minus by S. So this is also an S domain, but current form na. Current form is always circuit looks like parallel. So how to draw parallel equivalent in S domain. So here this terminal as usual V of S. This current is I of S. So when I write current means nodal equation. I of S equal to V of S by SL. So this must be SL. Then again another current source. What is this current direction? Downward. And its value is I0 minus by S. This is also S domain. It is a S domain or a frequency domain in parallel form. Parallel form. Whereas this one is also S domain in series form. So inductor time domain one circuit, frequency domain two circuits. One is in series form, other is in parallel form. Similarly, you can try for capacitor also. If you try for capacitor, same way. So V of t, capacitor C, I of t. So this is in time domain. What is the equation? V of t equal to 1 by C integral minus infinite to t, then I of t dt. Time domain equation. What is S domain? V of S equal to I of S by CS is one term. This is when 0 plus to t, but minus infinite to 0 also there na. That is initial value. Vc0 minus is a constant by S. So this is the voltage form. Voltage form is always series. So we can show the equivalent is here capacitor reactance of 1 by SC and here a voltage source, upper side plus minus, its value is Vc0 minus by S. These terminals again V of S, I of S. So when you write this mesh equation, again you get this expression. So it is in voltage form, sorry, frequency domain, series form, same frequency domain, current form. Here series. Current form is parallel. Voltage form is always series, current form is in parallel. So rest of the part you can do it. Solve for I of S, show them in parallel. So these circuits you should remember. Inductor voltage form, current form. Voltage form means series, current form means parallel. Capacitor also voltage form means series, current form is in parallel. So this is one problem I am solving. Then 4 problems they can ask. This problem, this format, or they may give this form also, or capacitor this form, or other form. Like that, these models we can solve. So this is also asked in GATE exam. So this is another problem. So many capacitors are there. Here switch K connected to A until it reaches steady state. Then move to B at t equal to 0. Move to B at t equal to 0. So that's a symbol speak that. switch K connected to A until it reaches steady state. Then move to B at t equal to 0. And after steady state, find I of t for t greater than 0. Find I of t for t greater than 0. So, what is this capacitor's equivalent? First, we can combine them. All these capacitors can be represented into single capacitor. 0.5, 0.3 parallel. So 0.8. 0.8 to 0.2 series. So what is C equivalent? 0.8 into 0.2 because they are series now. 0.8 plus 0.2. So that is 1. This is equal to 0.16 microfarads. 0.16 microfarads total C equivalent. Then it is connected to A until it reaches steady state now. So this capacitor total equivalent of this value is charged to 100 volts. So at 0 minus, at t equal to 0 minus, that is steady state. What is voltage in C equivalent? At this time is 100 volts. Is 100 volts. And when switch is connected to B, at t equal to 0 plus is initial value na? Is initial. So what is VCT? C equivalent to 0 plus. Sudden change of voltage in capacitor not allowed. So it is same 100 volts. Now after connected to B, so whatever voltage is there in the capacitor keep on decreasing, capacitor discharging through resistor of 5K. Now initially more current will flow, but he is asking expression for current. So now find I0 plus. What is I0 plus? As soon as it is connected to B, 100 volts divided by 5K. That is nothing but 20 milliamps. 20 milliamps. That is initial current. Then what is the final current after capacitor fully discharged? 0. So it is like when switch connected to A, mobile phone charging. When switch connected to B, mobile phone battery discharging. So charging and discharging. So discharging at t equal to infinite. What is the current? 0. After capacitor fully discharged, final current is 0. It is a first order. Even though we have so many capacitors, all of them we are combining into single one capacitor. Therefore, it is a first order. First order best technique is shortcut method. Shortcut method, what is needed? Initial value, final value, and tau. So next we have to find tau. Tau is nothing but R into C. So what is R value? 5K na? R is 5K and C equivalent is 0.16 micro. So what is this value? 80. 6.16 into 5. So you get 0.8 into here 10 power 3, 10 power minus 6 micro na? So effectively 10 power minus 3 seconds. So 0.8 into 10 power 3 or 0.8 milliseconds. You can also write to 0.8 milli. seconds is the time constant. We want I of t. So final value 0, initial value 20. So it looks like 20 e power minus t by tau. Tau is 0.8 milli. This 20 is in milliamps, na? Milliamps. So that you simplify, you will get 1250. 1250. This is 20 e power minus 1250 into t milliamps. This is valid for t greater than 0. So you can also multiply it with u of t, or we can write t greater than 0. This is the answer. So we got same answer. So capacity charging, how capacity discharging, we are understanding with this problem. So there's another problem. Some time domain equation is given. Time domain equation is given. Differential equation is given. I of 0 also given. Find the steady state value of current using Laplace transform. Find the steady state value of current. So first let us apply Laplace transform to that equation. So that is S into L I of S minus L I0. I0 is already given now, V0 by R plus R into I of t. So I of S is equal to V0. Laplace of 1 is 1 by S plus B constant using frequency shifting property. You get S plus R by L square plus 1 square is 1. You should know all the properties. Time shifting, frequency shifting, then time differentiation, time integration, initial value, final value, and so on. All the properties you should know. Now take I of S common. SL plus R is equal to V0 L by R plus V0 by S, V0 B by S plus R by L square plus 1. Then I of S is equal to, so that is all divided by this. That means I can write it as V0 anyway common, L by R plus 1 by S, B by S plus R by L square plus 1 divided by SL plus R. Now what we have, as per the question, what we have to find? I infinite. So using final value theorem, I infinite is nothing but limit S tends to 0, S into I of S. So further, this is equal to limit s tends to 0, s into that above we have to substitute. So V naught by SL plus R, L by R, 1 by S plus B by S1. So this is equal to simplify. So I can put one more step. V naught S into V naught L by SL plus R into R. Here S equal to 0 na, this term anyway 0. Then second term, this S cancel. Here S equal to 0. Here S equal to 0. This S cancel. What you get to V naught by R. Then this term. So this everything multiplied with this again multiplied with S. So that also 0. Just observe carefully. So this term 0, this term 0. You will get only V naught by R. This is the answer. So V naught by R. So this is a simple mathematics and limit s tends to 0. You are already familiar with limits now. So we'll get V naught by R. These are all different problems asked in GATE or IES. So all variety of models I'm solving. So this is another problem. Input is impulse, inductor, resistor, capacitor, all are in series. Here VR of t, VC of t. So find VC of t, VR of t using Laplace transform. So again, application of Laplace. Now, how to solve using Laplace? So because he's asking using Laplace transform, change the circuit into S domain. S domain. So inductor in S domain is what? SL. L inductive reactance is like inductive reactance. Inductive reactance is J omega L. J omega is nothing but SL. Capacitive reactance XC 1 by J omega is nothing but 1 by S. And initial value is 0. So SL, L value is 1, so it is simply S. Resistance will not change, 1 ohm. Capacitive 1 by SC. C is 1, so 1 by S. And what is the Laplace of impulse is 1. This is 1. Everything in S domain. Now this is VC of S. This is VR of S. So it is asking VC of t, VR of t. So if I know VC of S, inverse of that is VC of t. VR of S, inverse of that VR of t. So what is the expression for VC of S using voltage division? 1 into 1 by S by S plus 1 plus 1 by S. So this 1 volt is divided in this, we are finding voltage here, na? So input voltage into this reactance by total using voltage division formula. So simplify, you get 1 by S square plus S plus 1. This is VC of S. Now we want to VC of T. So to find VC of T, this can be further split into, verify later, 2 by root 3 by 2 S plus 1 by 2 square plus root 3 by 2 square. So if you expand the S square term, 2AB term is S, then 1 by 4 plus 3 by 4. 1 by 4 plus 3 by 4 is 1. And because here root 3 by 2, here root 3 by 2, here inverse 2 by root 3. Cancel. So that I can write inverse transform. Now from this, VC of T is equal to 2 by root 3 e power minus 1 by 2 T sine root 3 by 2 T. So this is answer for VC of T. Using inverse Laplace transform, frequency shifting property. So what is the formula if you want e power minus AT sine BT? What is the Laplace of this? Sine BT. BT Laplace is B by S plus A whole square plus B square. Na? I am writing this and this form. So inverse. So VC of T over. Next, an easy method is find IC of T. IC of T is nothing but C dVC by dt. So C value is 1 and d by dt of 2 by root 3 e power minus 1 by 2 t sine root 3 t. So differentiate u into v method. So I will give the answer directly. E power minus 1 by 2 t cos root 3 by 2 t sine by 2 t. So this is answer. And IR of t, IC of t, all are in series. Na? So IR of t is same as IC of t. Then we want VR of t. VR of t is nothing but R into I of t. What is R value given? 1 ohm. So I of t. I mean IR of t. So this is 1 into IR of t is nothing but IC of t. So the same thing will come. This. So right. E power minus 1 by 2 t cos root 3 by 2t 1 by root sine t. So this is the answer. If you solve this problem purely using time domain, it takes more time. So this is the technique. Another problem, initial value. So this switch K moved to B at t equal to 0, find d square I by dt square. This is the question. And after it is connected to B, what is the mesh equation? After connected to B, what is the mesh equation? 1K na R, so 1000 into I of t plus L di by dt plus voltage in capacitor is 1 by 1 micro 10 power minus 6 time 0 plus 2t only, then I of t d equal to 0. But we want to d square I by dt square. So differentiate again. 1000 di by dt to d square I by dt square 10 power 6 I of t equal to 0. So what we need is d square I by dt square. To solve this one, we should know I0 plus, we should know di by dt 0 plus also. Otherwise, you can't get this. But what is I0 plus? I0 plus depends on I0 minus. I0 plus is equal to I0 minus. But what is I0 minus? 0 minus which is connected to A, 0 plus which is connected to B, 0 minus is a steady state. Steady state inductor is shorted. So 10 by 1K. 10 by 1K. So that is 10 by 1K. So 1K is 1000 again. How much is this? 10 milliamps. I0 minus is 10 milliamps. Now di by dt 0 plus. Simplify this equation at t equal to 0 plus. So that is 1000. What is I0 plus 10 milliamps? 10 into 10 power minus 3 plus 2 I prime 0 plus and t equal to, this is anyway 0, equal to. So solve this. This cancel. And here only 10 is there. So what is I prime 0 plus? Minus 10 by 2. So minus 5 amps per second. minus 5. Now simplify this equation. 1000 into di by dt 0 plus is minus 5 plus 2 I double prime 0 plus 10 power 6 into I0 plus. What is I0 plus? 10 milliamps. 10 into 10 power minus 3 equal to 0. So what we want here, solve for I double prime. So this is minus 5000 I double prime 0 plus. This is 10 power 3. So 10 power 4. So now solve for I double prime 0 plus. So simplify this, you get this answer, minus 25 amps per second square is the answer. So form one time domain equation, differentiate again and again, solve for this. If they ask d to the power of 3, then this is the basic equation, differentiated here, again differentiate, d cube will come. So reuse previous values and find out I triple prime 0 plus and so on. Like that, any order we can do it.